Okay, so welcome. So last lecture we've seen a brief introduction to the outline of the course and the main content of the course, and we saw also in the second part some guideline on how to formulate and write down research questions that are like the starting point of any research. In this lecture, we will speak more about while research questions are the most abstract thing, let's say, in your research. Now we will look at the most concrete thing in your research, which are the data. And so we speak about data types, measures, and scale. You may have seen these things already in the past, but I'm like at least refreshing them. And I will show you today also about I will talk you with I will teach you about data collection methods, different data collection methods that you may encounter during your career and in software engineering research in general. So last time we saw some we gave an overview of the different empirical methods that are used commonly in software engineering. So we spoke about not in detail, but at least we mentioned about surveys, interview, experiments, case studies, literature reviews, judgment studies. Now the common thing between all these empirical studies is that they all entail some observation. As I showed in the other presentation in the previous lecture, you always start from some observation in the reality, and then you go back to the theory space, and then you move again to the reality to test your theory. Okay, so you always observe and you always have to collect some data. So any empirical method that I will teach you will need some form of data collection activity. Okay, so let's look at what type of data we will try to collect. Basically, there are two big families of data: the so-called qualitative data, which are mainly words, but could be also even images, could be diagrams. But in our case, we will mostly speak about those that can be treated as words, let's say, and that come from interviews, but also surveys, but also documents. And more recently, for software engineering, we've been studying also qualitative data sources such as social media opinions, called comments, and also app reviews, because if you have an app and you have several reviews, these reviews may contain information that is useful for software engineering, for software engineers to improve the app. So may contain additional requirements that the developers didn't consider at the beginning. And these are qualitative data. So qualitative data for you now is a synonym of words, okay? Quantitative data instead is numbers, okay? So they come from generally exact measurement that you do, and you can also do these measurements also on qualitative data, of course, because qualitative data can be transformed somehow also into numbers. How, for example, if I want to count how many times a certain word, certain relevant word is mentioned in a bunch of app reviews, I'm transforming words into numbers, into frequency numbers, okay? So I'm dealing with qualitative and quantitative data, and of course, qualitative data are less precise but more rich. Quantitative data are more precise, but the meaning is not always straightforward, okay? I need some interpretation. And some predetermined interpretation, because also on qualitative data, of course, I need interpretation. So given this distinction, let's start to give some definition, and then I will give you some example. This is the definition of a measure. So we're dealing with data, we want to measure data. A measure, let's read the slide. A measure is a mapping from the attribute of an entity to a measurement value, which can be numerical or categorical. Numerical is a number, categorically is a label. Again, a way of kind of a word of, or label or tag, let's say. So I'm measuring attributes of entities. What are entities? Entities are any object that I can observe in the world. And entities, such as, for example, an entity can be the source code in the software engineering environment, and an attribute of the source code that I want to measure is the complexity. For example, I have this code, and I want to understand how complex it is, how much complex, for example, because I would like to understand whether more complex code is related to more bugs. It has a correlation with the increasing number of bugs or increasing number of defects. So I can choose different measure for evaluate complexity. I can use a measure that can be the number of lines of code. It's a simplification, but of course it gives an idea that more lines also may imply more complexity. And the measure has a value. In this case, I wrote 1,000, so 1,000 lines of code. I can also choose to make another type of measure for the same attribute. So I have still the complexity to measure, but this time I want to evaluate the complexity as it is evaluated by a user, as it is perceived by someone who reads the code. So this person will not count the number of lines. This person will tell me, hey, this is very complex, or this is not complex at all. He will give an estimation that is based on a scale that I may decide, or I may interview him and try to infer which is the scale by interviewing several other people. But the simplest thing to measure this would be to ask him, hey, is this low complexity, average complexity, high complexity, for example? And so I have a measure given by a certain user. Of course, different measures may have different implications, because the lines of code is something that is objective. Okay, the evaluation made by the user may change for another user, so I have to consider that depending on the measure that I choose, I may have different implication in terms of objectivity and subjectivity of the measure, and I have different implication in terms of resources that I need to estimate the measure. Because, for example, for measuring 1,000 lines of code, I just need to count the lines in an automated way. In the second case, I need many users, many subjects, and compare and make an average of their evaluation to establish which is the value of my measure, the actual reliable value of my measure. Okay, but what is the overall goal of having measures associated to data? So having measure associated to attributes of the entity in my environment. The goal is to characterize and manipulate the attributes in a formal way. So once I have measures, I can do better comparison, I can do some statistics, okay? And the more the measure is exact, the more the measure is powerful, the more powerful statistics I can apply, okay? So let's look let's look at another definition. The definition is a scale, okay? As I said, the mapping of the attribute to a measurement value can be done in different ways, okay? Each way is a scale, okay? As I showed you before, I use different scale to evaluate the complexity attribute, okay? In this case, you see in the picture the entity that is source code. The attribute is again complexity. I can have a measurement value that is 1,000, the one that I showed before, and the scale is LOC, which is lines of code. Okay, I could use another scale, for example, number of variables to identify complexity, and is another scale. I can use the other complexity estimated by a user, okay, and the measurement value will be very complex, and the scale will be complexity by the user. Okay, evaluated complexity. I can invent, let's say, this different scale. Scale types. Okay, we spoke about scale. We understood that that they, as according to the example that I gave, they can be numbers, but they can be also words. So this already gives a hint that there is some differences in the types of scale. And here you have a list of the different types that go from the least powerful, the nominal scale, until the most powerful, the ratio scale. Okay, nominal scale are named values. So, for example, the one can be, for example, many, little, or can be also the type of defects. For example, in code, for example, or in requirements. For example, it can be this requirement is ambiguous, this requirement is incomplete. Okay. Basically, all nominal scale map the attribute of the entity into a name or symbol. Okay, it can be seen as a form of classification of the attribute. So types of code defects is a typical representation. Like, for example, this the code defect can be function is overly long, function is overly complex. Okay. Of course, in nominal scale, with respect to ordinal scale, you don't have an order. You have just classes, and you don't have an order between the classes. In ordinal scale, you still have labels, but these labels are ordered. Okay, the ordinal scale ranks the entities after an ordering criterion. Okay, so I say greater than, better than, more complex. For example, in this case, risk can be evaluated as catastrophic, critical, marginal, or negligible. Okay, you can have different level of risk, and catastrophic is greater than, in terms of risk, negligible, and is greater than critical. So you have an order in your scale. Interval scale, they introduce numbers, basically. An interval scale is used when the difference between two measures are meaningful, but the value itself is not meaningful. This is not directly intuitive I think it's not, it cannot be grasped at first glance. But you have to consider that this type of scale are the ones that are like the ordinal scale, but you have numbers instead of labels. And these numbers are useful because they allow you to establish a relative distance between two entities. Okay, these are not so frequent in software engineering, but imagine, for example, the temperature in Celsius or Fahrenheit. This is a typical interval scale. So the difference between 38 degrees and 39 degrees makes sense. It's 1 degree. But there is no actual meaningful zero value. Okay, it is a convention, the 0 Celsius. Okay, while the 0 Kelvin is a meaningful value because you don't have also negative values, for example. In a Celsius scale, the 0 value is a convention. Okay, anytime the 0 value is a convention, it is likely to be an interval scale. In software engineering, they are rare, but they can also be introduced in an experiment to evaluate some specific attributes. For example, if I want to evaluate the usability of a certain software tool, I can create a test that allows me to establish some score of the usability, and this score will be numerical, and will not have probably a 0 level of usability, a meaningful 0 level of usability. Okay, it will range, for example, between, I don't know, 5 and 10 or 5 and 15, because all the elaboration that I make on the test as answers to the test allows me to create this type of scale in which I have an order, and the difference between the values of usability is meaningful, but I don't have a meaningful 0. This is also for the same thing for the IQ. Okay, But in general, these are not so common in software engineering, but consider that you may need to generate them for your software engineering experiment. And finally, the ratio scale. The ratio scale are the more powerful. In this case, the additional thing is that you have numbers, but there is also a meaningful zero value. Negative value does not exist, okay? Do not exist. Meaningful zero value implies that you can do ratio, you can do division, okay? So the ratio between two measures in a ratio scale is meaningful, okay? This leads us to first consideration, first on some typical scales that are time and duration, and the other one about the power of the different scale, okay? Time and duration, what type of scale are them? Time can be considered an interval scale, while duration is a ratio scale. Time is an interval scale because there is no fixed start point. For example, we are considering like the birth of in a Christian community, we may consider the birth of Christ as the starting point of the time, but actually it's a convention. Okay, we decided one day that that was our zero for time, but time existed also before. That's why we are saying also before Christ. Okay. So there is for time there is no actual meaningful zero. Zero is a convention. While for duration is a ratio measure and indicates the amount of time something takes, and it has a meaningful zero because if zero time passed, this has somehow a meaning. Okay, and divisions ratios have meaning. Okay. For example, 20 seconds is twice as long as 10 seconds, and 10 days is twice as long as 5 days. Okay, so I can do this type of computation. So a division and multiplication. Okay, this leads us to the scale types and the power that they have. So also intuitively we understand that the nominal scale is the least powerful because I can count, like for example, just frequency of distribution of mode. And for ordinal scale, I can do something more, but not much. Interval scale are the ones for which I can start doing some real computation. For example, evaluate the median, the mean, and quantify the difference between each value, can add or subtract value. So interval scale are numerical scale, but do not allow me to multiply and divide values, mostly because the zero in this case is always a convention. Okay, irrational scale I have the true zero and I can do all of the operation. In software engineering, you will deal with all these type of scales, but it is important that you remember that they have different powers. Okay, different power. The scale has different power, and so this implies that some operation cannot be done on nominal scale, ordinal scale, and interval scale. So if you have an interval scale, you cannot do multiplication and divisions, and some operation are therefore, some statistics are therefore not allowed. Okay. Other characteristic of the measures, I already introduced some, gave a hint before about objective and subjective measure. Here you see a more precise description. An objective measure basically is a measure that does not require a judgment by an external subject. Okay, and the value is only dependent on the entity that is being measured. So you don't even if you measure it 10,000 times, you will always have the same measure, considering also, of course, the measurement error. Subjective measure, instead, they require some subject to perform the measure. Okay, and so there is a viewpoint that involved, and the viewpoint affects the measure. Okay, so it can be different if the entity is measured again, and normally they are nominal or ordinal scale type, like the ones that I exemplified before. For example, very complex or not so complex. Okay. Then there is a further distinction between direct and indirect measures. Direct measures are the one that involve measurements, do not involve measurements on other attributes, for example, line of codes, okay? And indirect measures are the more complex ones, so that are derived from a combination of different other measures or the involvement or other entities. So as we have seen, relevant measures in software engineering are often indirect. Okay, you rarely measure just lines of code. Okay, you most often want to measure complexity, usability. Okay, subjective, and you very often so involve some person in the evaluation of your measurement, and are normally expressed in nominal or ordinal scale. So they are not so powerful because you are always asking some people to do some evaluation. Okay, so also even the statistics that you can do are limited. Okay, however, and most of the times what we want to do in software engineering experiments and in software engineering research in general is try to link some internal attributes like code size, the color of the graphical user interface, to some external one. So perceived complexity, usability, etc. So you consider on one hand an internal attribute, and you want to understand to which extent it relates to an external attribute. Okay. The real thing, as I was telling before, is that you normally could not apply advanced statistical analysis to when you use this measure, because they often indirect, subjective, nominal, and with ordinal scale. But we do it anyway. Okay, this is a violation of sometimes of some statistical assumption, but some information, some little information is better than nothing, and we should always be aware of the validity of our conclusion. We will go through the issue of validity very frequent. We encounter this issue of validity very frequent in this course. If you are curious, you can refer to this paper, in which there is a discussion on how, despite the fact that using some measure is not that applying some certain statistics is not appropriate in software engineering, we do it anyway, mostly because having an indication is better than knowing nothing. Okay, so if you want to know more, please refer to this paper. So now let's do a little break, and let's pass afterwards to the other